Hello everyone. In this video, we are going to discuss about problem 4.2 from the unit for chemical bonding and molecular structure, class 11 chemistry. See, the question is, write the Lewis dot structure of nitrite ion, that is NO2 minus ion. So we have to follow 3 steps to write the Lewis structure of a particular Lewis dot structure of a particular ion or molecule, like that. So here you see the step 1 is count the total number of valence electrons in the nitrite ion. See, here we have, in the nitrite ion we have 1 nitrogen atom and 2 oxygen atoms. Okay, 2 oxygen atoms. Alright, nitrogen has atomic number 7. So its electronic configuration 2, 5. Oxygen atomic number 8. So electronic configuration 2, 6. Okay, so when we count the total number of valence electrons in the nitrite ion, you see there is 5 valence electrons in the nitrogen atom. There is 6 valence electron in the 1 oxygen atom and 6 valence electron in the second oxygen atom. Okay, additionally, there is a negative charge here. Negative charge which is equal to an electron. So, one negative charge is actually equal to 1 electron. So, plus 1 electron. Okay, so total number of valence electrons, 5 plus 1, 6. 6 plus 6, 12. 12 plus 6, 18. So, total 18 valence electrons are there in the nitrite ion. Okay, now the step 2. Draw the skeletal structure. Draw the skeletal structure. How to draw the skeletal structure? You see, we have 1 nitrogen atom and 2 oxygen atoms here in the nitrite ion. So, nitrogen, when you compare nitrogen and oxygen atoms, nitrogen is least electronegative or less electronegative than oxygen. Nitrogen is less electronegative than oxygen. So, we have to place the nitrogen at the center and place the 2 oxygen atoms around the nitrogen. Okay, this is how we draw the skeletal structure. Nitrogen is less electronegative, so that is placed at the center. Then oxygen atoms are placed around it. Okay, now the third step, step 3, connect atoms with bonds. Okay, so here the skeletal structure we have 1 oxygen here, 1 nitrogen here and 1 oxygen here. Okay, I am just naming it as 1, 2 and 3. Alright, now we have to connect these atoms with bonds. So let us first form a single bond between this oxygen and nitrogen and a single bond between this nitrogen and oxygen. See, a single bond uses 2 electrons. This single bond uses 2 electrons. So 2 plus 2, 4 electrons are used here. Total 18 valence electrons are there. 2 plus 2, 4 electrons are used by 2 single bonds. So the remaining number of electrons, that is actually equal to 14. Now we have 14 electrons. Okay, now we have to complete the octet. First we have to complete the octet for the outer atoms. That is these 2 oxygen atoms. See, I am considering the first oxygen atom here. To complete the octet, it needs 8 electrons around it. Single bond uses 2 electrons. So we have to place 6 electrons around this oxygen. Okay, so 14 remaining electrons were there. 6 are used here. So 14 minus 6, which is equal to 8 remaining electrons are there now. Now we have to consider this outer atom oxygen. Okay, to complete octet, it also needs 8 electrons around it. The single bond uses 2 electrons. So 6 more electrons are required. So 6 electrons are placed here. 8 electrons were there as the remaining electrons. Now 6 have been used here. So 8 minus 6, which is equal to 2. Now the remaining number of electrons, that is equal to 2. So we have to place that 2 electrons around this nitrogen atom. Okay, so you see octet is completed for oxygen because 6 plus 2, 8. 6 plus 2, 8. Single bond uses 2 electrons. So 2, 2, 2, 2. Okay, but what about nitrogen? When you consider this nitrogen, the single bond uses 2 electrons, this single bond uses 2 electrons and 2 electrons here. So 2 plus 2 plus 2. Only 6 electrons are there around the nitrogen. Okay, so this structure does not complete octet for nitrogen. it requires 2 more electrons. So single bond does not satisfy the octet rule or octet condition for the nitrogen atoms. So this structure is not valid. So we have to try a double bond between this oxygen and nitrogen atoms. Okay, or you can try a double bond between this nitrogen and this oxygen atom, no problem. So single bond is not enough to satisfy the octet rule. So we are going to try a double bond. So I am going to try a double bond between the first oxygen atom and this nitrogen atom now. Okay, and a single bond between nitrogen and oxygen atom. Okay, so you see total 18 valence electrons are there. We have placed a double bond between the first and this first oxygen atom and the second nitrogen atom. So 2 plus 2, 4 electrons are used here. And a single bond between, already it is there, no? A single bond between nitrogen and oxygen. So 2 electrons here. So 2 plus 2, 4, 4 plus 2, 6. 6 electrons are used here in bonding. So now we have 12 remaining electrons. Okay, so we have 12 remaining electrons here. So we have to complete the octet for the outer atoms now. For this oxygen, this double bond, it uses 4 electrons. So 4 more electrons are required here to complete 8 electrons around it. So 2, 2, 4. So 2, 2, 2, 2. Total 8 electrons are there for this oxygen. So 12 minus 4, which is equal to 8. Okay, so 8 electrons are there now remaining. Now let us complete the octet for this outer oxygen atom. The single bond uses 2 electrons. Here we have 8 electrons. So this actually requires 6 more electrons. So 2, 4, 6. So octet is completed for this oxygen atom because 2, 2, 2, 2. 4 2s are 8 electrons are there around this oxygen atom. So here now we have used 6 electrons. So 8 minus 6, which is equal to 2 electrons are there as remaining electrons. Okay, so I am going to place that 2 electrons around this nitrogen atom. Now what about the nitrogen atom? Is octet is completed for this. You see double bond. So 2, 2, 4 electrons are used here. There is a single bond here around this nitrogen. So 2 electrons are used here. And there is a lone pair, non-bonding electron. 2 electrons are here. So 2 plus 2, 4 plus 2, 6 plus 2, 8. 8 electrons are there around this nitrogen atom. Okay, so you see this is a valid structure. But here you see we are talking about the nitrite ion. So there is a negative, this is a negative ion. Okay, so since this is a negative ion, we write like this. There is a negative charge here like this. So this is actually the valid Lewis dot structure for nitrite ion. And you see there is one more valid Lewis dot structure for nitrite ion, that is this one. Okay, so these two are the two valid Lewis dot structures for the nitrite ion, and these two are actually called as resonance structures. Okay, so I hope